Understanding motion. In the childhood, we notice moving objects like cycle, car, etc. Our parents tell us that the cycle is moving and the car is moving, and the child understands about motion by observing these objects, moving objects. And when he grows up, and if he is traveling in a train, when he is in a train which is at rest, if he looks at a train, if he observes a moving train, suddenly he feels as though his train is moving and the other train is at rest. Even though he observes a moving train, suddenly he feels as though his train is moving and the other train is at rest. But he will be perplexed, and if he watches the ground, a tree or any other object on the ground, suddenly he notices that his train is at rest. He will be perplexed with this result. Something new thought comes to his mind. What is this? Am I at rest or am I moving? So far, the child is given the concept that the earth is at rest. So initially, while talking about motion, we feel as though the earth is at rest and all other bodies, moving bodies, are with respect to the earth. They are moving with respect to the earth. This relative concept is not understood initially. So, our observation is based on this relative concept that our concept is the earth is at rest. But the real understanding is wherever we are situated, we feel that body is at rest. That is called the frame of reference. If you are in a moving train, remove the concept of the constant earth and sit in a train and watch the surroundings without looking at the earth. You will notice that all other objects are moving relative to the train. Though you are seated in a moving train, you notice that all other objects are moving and the train is at rest. So we feel as though our frame of reference is at rest. Since we are on earth, we feel the earth is at rest and we observe the motion with respect to the earth. But motion is relative. Whenever you are situated in a frame of reference, you feel you are at rest in that frame of reference and we observe motion with respect to that frame of reference. This is understanding relative. To understand rest or motion, to understand rest and motion, we need to take a body. We need to take a body to be at rest. And by considering that body at rest, we study the motion of all other bodies. For example, if we consider earth to be at rest, we consider all other bodies to be either they are in motion or in rest. So we study the motion of the bodies with respect to earth. So earth is considered as a reference body. We consider it to be at rest. This we call as frame of reference. In scientific terms, we call this as frame of reference. And we attach a coordinate system. We attach a coordinate system to this frame of reference or earth, and then we study the motion. This can be explained, can be understood easily by considering the mathematical number line. That means on number line, we take a point and we consider it to be the origin. From this line, we measure the distances. From this reference point, from this reference point 0, we measure the distances. So like this, we consider a position. That position is considered as a reference point. From that point, we try to measure the motion. So for example, let us take the number line and study the motion. So mathematically, we study motion using a reference point like origin. On the number line, we keep several points at equal distances, and we consider their positions to be 1, 2, 3, 4, etc. from the reference point, or from the origin O, we consider these points to be at distances 1, 1, 2, 3, 4, etc. They may be in either meters or centimeters or in another scale. So their distances are taken in several in systems. Like this, we measure the distances of these points. Position of a body. If the body is at the origin, it is its position. If the body is at 2, this is its position. When the body is at 4, this will be its position. So like this, the point where it lies is its position, and its position will be measured from the distance, by the distance from the origin. So we can assess the position of a body by using, we determine the position of a body by using the reference point O. Sometimes it will be to the left of the origin. Then we consider these positions as negative. Sometimes we consider positions to the right as positive and positions to the left as negative. Like this, we can assess the position, or we can represent the position of any body on a number line. Motion of a body. If the position of the body is changing, that means if it moves from origin to 4 units, then its position has changed from 0 to 4. So then we say it is in motion. If its position changes from 4 to 8, then we say it is in motion. Like this, if the position is continuously changing, if the motion is continuously changing, then we say the body is in motion. The body is in motion. The motion from left to right is considered as positive, and the motion from right to left is considered as negative, So the motion from 2 to plus 2 to plus 6, this is plus 4 units, and the motion from plus 8 to plus 2, it is minus 6 units, Like this, we take the motion to be positive in one direction and a negative in the opposite direction. The motion will be considered as positive in one direction, and the motion in the opposite direction is taken as negative. Like this, we measure the motion with positive and negative quantity. Distance traveled. If a body starts at plus 2, and goes to plus 8, and then come back to origin and goes to minus 2, then in the first case it has travelled 6 units. In the second case, it has travelled 8 units, and in the third case it has traveled 2 units, so it is 6 plus 8 plus 2, that is 16 units. The total distance traveled by it is 16 units, but its motion started at +2, that is its initial position. Its motion ended at -2, that is its final position. Its initial position is +2 and its final position is -2. Its positions are +2 and -2, but the distance is traveled, the total distance traveled is 16 units. This motion took place in 3 stages: initially 6 units, then 8 units, and then 2 units. Like this, we measure the distance traveled and we identify displacement. Displacement. It is the straight line distance. It is the straight line distance from initial position to final position. Initial position to final position. In the above example, the initial position is +2, the initial position is +2, and the final position is -2, and the final position is -2, and the displacement is 4 units. The displacement is 4 units, and the direction of the displacement is negative. The direction of the displacement is negative because it is from right to left. It is from right to left. So the displacement is -4. Though the distance traveled is 16 units, the displacement is only -4 units. So displacement is considered as the straight line distance from initial position to final position. From initial position to final position.